Hi, everybody. This is Dr. Nigro. This screencast is to help with calculations related to density. All right, so density is the mass of matter within a certain volume. All right, you should have already completed the note sheet on this. So this definition is really something we already know. All right, now for our table, we've got variables, density, mass, and volume. Each have a symbol. So for density, the symbol is a lowercase d, and the units we see here tend to be grams per milliliter, or sometimes you see grams per centimeter cubed. All right, for mass, we use a lowercase m, and our unit there is going to be grams. And then for volume, an uppercase V, and we either have milliliters or we see centimeters cubed. All right, so those are the variables and those are the units that we're going to see. The formula for density, so density equals the mass of the object divided by its volume. All right, for our triangle, now you don't have to use the triangle. It's some kids like it, some kids don't. It's kind of up to you. But the way it works is we mirror the formulas. We put mass up top, density, and volume, and it's kind of dividing these two, mass and density, that equals volume, or mass divided by volume equals density, or mass equals density times the volume. So we get our three formulas: density equals mass over volume, mass equals density times volume, or volume equals mass divided by density. All right, now you don't have to memorize these formulas. I'm going to let you have this figure. So you're going to have them. What I need you to do is be able to recognize when to use them. All right, so we really need to watch our units when we work these problems. We've done some work in the metric system, so you just have to be on the lookout. We want grams in its base unit, and for liters, we want it in the milliliter. All right. When working problems, I strongly suggest that you organize your information into a table. I'm going to have some examples for you. The table really lets you see what the problem has given you and what the problem asks for. All right, once you know what you have and what you want, you can choose the correct formula from these three, plug in what you know, and solve for the unknown. All right, so I'm going to go through a couple examples with you. I'm going to skip around a little bit, and then you are going to work a couple on your own. All right, so for our first problem, we have what is the density of a piece of metal with a volume of 60 milliliters and a mass of 350 grams. All right, so we look, the what is the density. So our unknown is going to be density. All right, we have a volume of 60 milliliters. So I'm going to put that in my table with the volume. And then we have a mass of 350 grams. All right, so I'm looking for density. I have mass and volume. So my formula is going to be density equals mass divided by volume. All right, so I come over here. I always write my formula without the numbers in it first, just as a reminder of what I'm doing. And then I plug in those values. So 350 grams for the mass, 60 milliliters for the volume. I get out my handy calculator. I type everything in, and I find that the density of the substance is 5.83 grams per milliliter. All right, now make sure that your answer has units attached. All right, these are measurements, so we need to make sure they have a unit. All right, so that was pretty straightforward. Let's move on to number 2. This one says what has a mass, or what is the mass? So our unknown is going to be the mass of a 250 milliliter volume of a liquid with a density of 0.708 grams per milliliter. So our volume is given as 25 milliliters, and our density is 0.708 grams per milliliter. All right, now this time we're looking for mass, and if we look back above, we'll see that mass is equal to density times the volume. So mass equals density times volume. So I come over to the side, I write out my formula, and then I'm going to plug in my values. So the density was 0.708 grams per milliliter, and our volume was 25 milliliters. All right, again, we get out our calculators, we multiply those two numbers together, and we find this substance has a mass of 17.7 grams. All right, let's try one more. All right, this one says what is the volume. So our unknown is going to be the volume of a sample of carbon tetrachloride with a mass of 75 grams and a density of 1.6 grams per milliliter. So for mass, 75 grams, and for density, 1.60 grams per milliliter. And this time we're looking for the volume. So if I go back to my formulas, I can see that the volume is equal to mass divided by density. So mass divided by density. So volume equals mass over density. And I plug in my numbers, 75.0 grams for that mass, 1.60 grams per milliliter for that density. Calculate that division. So 75 divided by 1.6 is equal to 46.9 milliliters. And that would be the volume of this substance. All right. Now I'm going to let you try this one on your own, number 4. So if you want to pause the video for a second, go ahead and work that one. All right. And then turn it back on. All right. Hopefully that went well for you. All right. I want to look at numbers 5 and 6 together. These are a little different than what we've been doing because of the volume piece. All right. Now we're going to do a lab in a couple days where we're going to look at how to calculate density through experimental means. All right. And one of the ways we're going to do that is something similar to this problem. All right. So this says determine the density of a rectangular piece of concrete that measures 3.7 centimeters by 2.1 by 5.8 centimeters. All right. And has a mass of 43.8 grams. So the density is my unknown. The mass is 43.8 grams, which means I've got to be able to determine the volume. And the way I do that is I think about my substance in terms of 3 dimensions. And I've got 3 measurements. I've got 5.8 centimeters, and I've got 3.7 centimeters, and 2.1 centimeters. And to find the volume, I need to multiply the length times the width times that height. All right, so I'm going to take care of that down below here. So if I plug in 3.7 centimeters times 2.1 centimeters times 5.8 centimeters, I'm going to get a volume of 45.1 centimeters cubed. All right, so remember when I told you the units for volume, I said it would be milliliters or centimeters cubed. This is an example of where you would have centimeters cubed. All right, so I found the volume using the length times width times height, and I found that value to be 45.1 centimeters cubed. All right, now with the volume and the mass, I can go back to my density formula. So density is mass divided by volume. So we're going to have 43.8 grams divided by 45.1 centimeters cubed. And the density of this piece of material is 0.97 grams per centimeter cubed. So this is an example where that density unit includes that centimeters cubed. All right, so if you have a regularly shaped object and you know the formula for how to find the volume of that object, you can make the measurements, use the formula, and solve for the volume. And then from there, use your density formula to find that density. All right, but what if the object isn't regular? All right, we did a lab where we looked at volume by displacement, where we looked at a rock and we had a volume measurement in our graduated cylinder of water. We took that measurement and then we dropped the rock in and we saw that measurement change. The difference between those two values was equal to the volume of the rock. All right, well, that's something similar to what we see in number 6. A rock is dropped into a graduated cylinder containing water. The mass of the rock is 24.5 grams. The initial water level is 23.6. After the rock is placed in the water, the level rises to 58.2 milliliters. All right. So what we've got here is a mass value of 24.5 grams. All right. We're looking for the density eventually, but first we're going to need to find the volume. All right. So the volume of our rock is going to be equal to the volume level after we add the rock minus the volume level before we add the rock. All right, so in this case, 58.2 milliliters after the rock is added minus 23.6 milliliters, that initial or original value. And we find the rock has a volume of 34.6 milliliters. All right, so I'll put that in my table. All right, and the formula I'm going to use is my density formula, mass divided by volume. All right, so I come down for part B, put in my formula, and then I take the 24.5 grams and divide it by my mass value, which was 34.6 milliliters. And I find that this rock has a density of, oh, wait, I forgot to calculate this one. Hold on just a second. Let me get a calculator. Okay, so 24.5 divided by 34.6. We find we have a density of 0.708 grams per milliliter. All right, now that, obviously, this problem is not a great problem. The, the density of the rock should be higher than that. Rocks sink, so they should not float on top of water, but it's okay. All right, so this was a two-part. You had to do first to find the volume of the rock. We did volume by displacement, so volume by displacement. And then part two was to use our density formula, okay? All right, so I'm going to leave 7 for you to try on your own as well, and then there will be some additional problems for you to practice. I mean, if you have any questions, please let me know.